I don't know what that means, but whatever. Okay, let's do this quickly. Did you guys check your problems on the graphing calculator? Okay, number 1G. So, are you guys doing it in less than a minute? Like this, watch this. You go, x-intercepts plus or minus 1, y-intercept 1, vertical asymptote, no more, horizontal asymptote, y equal negative 1, and then you just go. What was the problem with that?
There's nothing else?
Wait, let me look. No. Right? When the graph goes out here, you follow the horizontal asymptote. Okay, H. No. Oh, F. Thanks for putting F before G. Y equal 1 plus x squared all over 1 minus x squared. Hey, that's just the reciprocal of this graph. Okay, so x-intercept no more, y-intercept is 1. Vertical asymptotes are x equal plus or minus 1. The horizontal asymptote is going to be y equal negative 1. And then so over here it's got to be down here, because if you drew it up here it would cross the x-axis. But then since it's exploding on this side, it's got to explode on this side, got to pass through it and it's got to go up. How come it doesn't go down? Because otherwise it would cross the x-axis. There's no x-intercepts here. In fact, there's no x-intercept at all. And since it's exploding up on this side, it's going to explode down on this side, and then you follow the horizontal asymptote. Right? Because isn't this the same thing as 1 plus x times 1 minus x? They're both to the first power, so if it's exploding down on one side, it's got to explode up on the other side, right? Odd power. Well, what was the problem? If you tell me the problem, I can tell you the solution. Oh, now, well, you write on the board, but there's no problem. All right. You're going to play that game, are we? 3x squared over x squared plus 1.
Is that carried?
Yeah?
Okay.
There's a K up there, right? Okay, x-intercept 0, y-intercept 0, vertical asymptote no more, horizontal asymptote y equal 3. Did you at least get those 4 things? Okay, then gotta do this, right? Actually, this graph. The graph should be symmetric about the y-axis because it's even, right? If you plug in negative x for x, you get the same thing. In fact, all of these 3 are all even functions. Do you guys even think about that when you graph? Like, oh, you plug in negative x for x, you get the same thing. The graph should be symmetric about the y-axis. And then how come the graph bounced off this x-intercept? Yeah, because you get an even power. That's why. See how it all fits together? You just gotta practice a few of these. This is just like shooting free throws. Just do a few. And then L. Y equal x squared minus x minus 2 all over x cubed minus 3x plus 2. Well, did you guys factor it? So if you factor the top, what is that? X minus 2 times x plus 1. And the bottom, you have to do synthetic division, right? So if you do synthetic division, you get x minus 1 squared times x plus 2, correct? Okay, so x-intercept, 2 and negative 1. Y-intercept, negative 1. Vertical asymptote, x equal 1, x equal negative 2. And then horizontal asymptote, y equals 0. Does it bother you that 2 points are right on the horizontal asymptote? No, because they only take effect on here. Okay, so look, here are your clues, right here. The graph got to go through here, and it's got to go down, right? How come it can't go up? because there's no x-intercept there. And then, I'm coming to this point, do I bounce off or go through? -1 came from this factor, has an odd power. It's going to go through, and then it's got to do this, right? It's not going to go through and then come back down because there's no x-intercept there. And then, since the thing is exploding up on this side, then on this side what? How do I know it's exploding down? Because -2 came from here, odd power. And then, I don't know what to do, Mr. Park. You follow the horizontal asymptote. Now on this one, since this one is exploding downward, what's going to happen? The other side is what? Up or down? Down, because 1 came from here, it has an even power, so it's going to explode the same way. Then I'm coming to this point, go through or bounce off? 2 came from here, odd power, it's going to go through, and then I don't know what to do. Pterodactyl. As the graph goes out here, you got to get closer to the horizontal asymptote, whatever it is. That's how rational functions work. If you draw in a horizontal asymptote and your graph is not getting closer to it out here, then that's like a major error. That's what the horizontal asymptote does. It gets closer and closer to it. Oh, so that's all the questions. All right. Okay, now tonight's homework. First of all, okay, we're going to talk about other asymptotes besides horizontal asymptotes. But here, why don't we just look at this graph and I got to go over a few things. Did you guys learn about limits last year? Have you heard that word, limit? Honors people? Okay, the regular people heard. What about the honors? Limit. Paige? Okay, use it in a sentence. The speed limit is 35 miles per hour. No, in a math context. Where did you learn limits last year in math?
The math speed limit is...
I'll give you a math speed limit. Come on. Okay, what about the number E? How did you learn the number E last year if you don't learn about limits? Yamaguchi. Okay, what do you know about the number E? What's E?
Oh wait, that's the thing that's the
It's like 2 point something.
Yeah.
Yeah, E is equal to
2.
2.718. We're going to learn this next chapter. 1828459045, and it keeps on going without repeating, right?
Mr. Park, this isn't in the notes.
No, this is next chapter, I said.
Oh, is this the 1828, 1828?
Oh,
45?
okay, how come Cap knows?
Yeah.
How does Cap know? Anyway, where did this number come from? Mason?
This is like 1 plus 1 to n to the.
There you go, and what about it?
It's like the limit as n approaches.
There you go. It's the limit as n approaches infinity of 1 plus 1 over n to the nth power. You guys never saw this last year? That's what E is. What did your teacher say last year? Just memorize. E is 2.7.
Okay. I didn't remember using E.
Are you kidding me?
You didn't use it.
Of course, if you had to have learned E. So you never saw this then, lim, which stands for limit. Are you? Once again, I took my blood pressure medicine. Okay, so, calm down. Anyway, I'm going to teach you then. Okay, so look at this graph. What if I were to ask you, what is the limit of this function as x approaches infinity? What the heck does that mean? That means as x gets larger and larger and larger, like a million, a billion, a trillion, then the y coordinates of the graph are getting closer and closer to what number? Now look at this graph. As x approaches infinity, in other words, as the graph goes out to the right, the y coordinates are getting closer and closer to what? -1. Why is that? That's because that's what the horizontal asymptote is. It's getting closer and closer to it, right? What is the limit of this function as x approaches negative infinity? That means when x is super large negative, like negative million, negative billion, negative trillion. In other words, as the graph is going out to the left, the y coordinates are getting closer and closer to -1, because that's what the horizontal asymptote is. What is the limit of this function as x approaches 1 from the left side, from the negative side? Okay, here's x equal 1 right here. Coming from the left side, look at the graph. Coming from the left, what's happening? The thing is just exploding upward. What do you think the limit is? Yeah, infinity, because the y coordinates are just getting really, really big without bound. What is the limit of this function as x approaches 1 from the right side? So here's x equal 1. Coming from the right side, what's happening to the y coordinates? Negative infinity. And this is how we describe asymptotic behavior. So you have to get used to this limit notation right here. You've never seen this before. Well, it doesn't matter, I thought. Don't they always teach you like you don't know anything? But you guys gotta pick it up. You guys just leave it on the floor. That's what happens. Okay, what are we doing today besides this? Oh, what happens when the degree of the top is bigger than the bottom? That's what we're doing today. So I think 2 examples will be enough to finish early. Okay, so y equal, let's do something, x squared minus x minus 2 all over x minus 1. First of all, does it, if I factor the top, will it cancel? The thing on the bottom? No. Okay, so why don't we just leave it like this? Or I guess you could factor it. And by the way, the quiz is not going to be on Monday, it's going to be on Tuesday. Let's factor it anyway. So I can't cancel anything. So let's go through that 4 things that we learned yesterday. X-intercepts. You guys should be experts by now. 2 and -1. Y-intercept. I don't know if you know this, but when you find the y-intercept, it's easier to look at this one because you can just do that, right? Vertical asymptote. What? X equal 1. You look at the denominator. What makes the denominator 0? Horizontal asymptote. What happens when the degree of the top is bigger than the bottom? Then there's no horizontal asymptote. So, what happens when the degree of the top is bigger than the bottom? There's no horizontal. Is there something else? Yes. If the degree is bigger by 1, you have a slant asymptote. If the degree of the top is bigger by 2, then you get a parabolic asymptote. If the degree of the top is bigger by 3, then you get a cubic asymptote. But in this class, we're only going to do bigger by 1, slant asymptote. But you just have to be aware that there are other asymptotes. Okay, now how do you find the slant asymptote? Well, okay, wait. You know why? Yesterday we ran out of time. Okay, let me give you something from yesterday. 2x minus, is this the example what was the example we did in class? Was it this? Yeah, okay, let's do the same thing. Now, right now you guys know that the horizontal asymptote is y equal 2, but why? Because I gave you a rule. That's not why. I gave you a rule, right? If the degree of the top and the bottom are the same, you look at the coefficients. But why is that the horizontal asymptote? Well, what does this bar here mean? Divide. So let's actually divide. You want to do long division or synthetic division? Okay, synthetic. So 2, -1. What do I put in the box?
-1.
Okay, do synthetic division. 2. -2. Okay, so there you go. So if I divide this by this, what are you going to get? What's the quotient? 2 plus the remainder over the divisor, which is, what's the divisor? X plus 1. So if you divide this by this, that's what you're going to get. Now, somebody tell me, why is it when the graph goes out to the right and goes out to the left, in other words, when x is really large, it gets closer and closer to 2? What happens when you plug in a really huge number for x, like 1 billion? What happens to this? Yeah, it gets closer and closer to 0. So that's how we do it. It gets closer and closer to 0. So as x approaches infinity, this thing gets closer and closer to 0, and therefore the whole thing gets closer and closer to 2. And that's why it's the horizontal asymptote. So we can do the same thing with this over here. This bar means divide I'm going to divide. So you want to do long division or synthetic division?
Synthetic.
Okay, good choice. So 1, negative 1, negative 2. What do I put in the box? 1. Drop the 1 down, multiply, add, multiply, add. Did I do that correctly? Okay, so if I divide this by this, what are you going to get? What does this stand for? 1x plus 0 plus the remainder over the divisor. So as x approaches infinity or negative infinity, when x is like really large, what happens to this? It gets closer and closer to 0, right? Because negative 2 over a billion minus 1 is like almost 0, right, already. So what's left then? Yeah, so this is your, what we call slant asymptote. Some books call it oblique asymptote. Same thing. So again, as the graph goes out to the right and the left, you will be getting closer and closer to the line y equal x. Right here. This is your, and that's how you find your slant asymptote. So you just divide. And you can just disregard the remainder because as x approaches infinity, it gets closer and closer to 0. So whatever your quotient is, that's going to be the slant asymptote. Okay, and then you do the same thing. Either the graph is going to be down here like this, or it's going to be up here like this. Which one do you think it is? Yeah, it's going to be up here because it's got to pass through the points that you plotted. So it's going to look like this. Everybody understand why it can't be down here? Because if it were down here, it would cross the y-axis. There's no y-intercept. The y-intercept is up there. Because every year the students ask, how come you can't have both? Well, if you had both, it wouldn't be a function, right? This is a function. It has to pass the vertical line test. And then, using the reasoning from yesterday, if the thing is exploding up on this side, then on the other side of the vertical asymptote, what? Is it up here or down here? What did we learn last night? The odd power. If it's exploding up on one side, it's going to explode down on the other. Go through this point, and then, what do I do? As the graph goes out to the left and the right, it has to get closer and closer to the y equal x asymptote. Same thing, except it's just not horizontal, it's slanted. So as the graph goes out here, it gets closer and closer to the slant asymptote. Okay, let's do a tougher one. That one was too easy for us, yeah? That's an insult to our loins. Okay, let's do, I hope I'm not picking ones that are in your homework. Y equal, I'm going to give it to you in factored form. X cubed, let's do the one from yesterday. This over x squared, silence! Minus 1, minus 1, what? Say that again? Minus 1 plus 2, so plus 2. What did I just say? Minus 1. Plus 2, so we want plus 1 minus 2. Minus x minus 2. Okay, let's just hope this works out. Okay, what's the first thing you should do? Notice that the degree of the top is 1 bigger than the bottom, so that's where you're going to get the slant asymptote. So what's the first thing I should do? You should factor it. You know, if you're lucky on the quiz, I might give you both forms. Is that what you guys want? Because some of you might screw up the synthetic division and then all hell's going to break loose. So shall I give you like both of them?
Yes.
How about saying, Mr. Park, no need, just give one, I can do the other. Or what if I give you that one and you're going to multiply it out to get that one?
No.
That's awkward.
You rather,
I'd rather factor.
I didn't offer. Okay, let's go through the 4 things. X-intercepts. You probably want to look at this. 1, negative 2. Y-intercept. It's probably easier to look at this one because you can just do that, right? Negative 1. Vertical asymptote. It's probably easier to look at this one. So x equal 2, x equal negative 1. Okay, horizontal asymptote, no more, right? Because the degree of the top is bigger than the bottom. But since it's bigger by 1, there's going to be a slant asymptote. And how do we get it? We gotta divide. Now, do you guys remember how to do synthetic division when you divide by 2 linear factors? Or shall we just go with the tried and true long division? Yeah, remember there was something we did, remember? Nobody remembers, let's just do long division. Yeah, what's wrong with long division?
It's too.
No, too late. I like long division anyway. Because it's fun. That's why you do things, right? For fun. You don't do it because you have to, right?
Yeah.
Like what? Give me one thing.
Go to school.
It's optional. Everything in life is optional. If you don't like it, just stop. Honestly, people, x squared goes into x cubed how many times? Just like this class, if you don't like it, just stop. You can go to regular.
Can you not stop anymore?
Well, you cannot drop math because you got to take math through your junior year. But then you don't even have to come to ELI, right? That's optional. Everything in life is optional. X squared goes into x cubed how many times?
1.
See?
What's that?
X. Multiply that times the divisor. We didn't we just finish long division not too long ago? Okay, go. Subtract. No, we're subtracting x squared.
Minus x.
Hey, something's wrong here. We did something wrong. Something's wrong here. What did we, somebody look, what did we do wrong?
Isn't it just one time for the x squared?
What? Say that again?
No, I don't know.
We did something wrong. Oh no, we didn't do anything wrong. We did it right. That was what was throwing me off. Because we did it right. Okay, x squared goes into x squared how many times? Plus 1. So multiply that times the divisor. X squared minus x minus 2. Subtract. We cannot subtract that. Are you kidding me? 4. So what's the answer then? The answer is the quotient plus the remainder over the divisor. So tell me, what's the slant asymptote? Y equals this, because as x approaches infinity or negative infinity, this thing here gets closer to 0. So whatever the quotient is, that's your slant asymptote. So the slant asymptote is y equal x plus 1. So now we are ready to graph. Is the graph up here, or is it down here like this? So it's only two. It has to be up here. Why? Because it's got to hit the x-intercept that you plotted. Now, though, if it's exploding up on this side, how do I know it's exploding down on this side? Because negative 1 came from this factor odd power. In fact, on both, they both have odd power, so it's going to be opposite way on both vertical asymptotes. Okay, I'm coming up to this y-intercept. Go through. Now, what do I do? Bounce off or go through? Bounce off or go through, quick! You bounce off, how come? Because this x-intercept came from this power factor which has an even power. And then if it's exploding down on this side, it's got to explode up on this side. Why? Because 2 came from this factor, has an odd power, and then I don't know what to do. You get closer, as the graph goes out here, you got to get closer and closer to whatever the slant asymptote is. Just like last night, you had to get closer and closer to whatever the horizontal asymptote was. And there you go, that's what the graph is like. Why is this the, so it's the same thing as last night's homework. Instead of the asymptote being horizontal, it's just slanted now. Why is that a problem? Okay, I just want to show you one more problem and then we're done. What time is it? 15 minutes early, not bad. Remember we did this problem when we did lim quad? Square root of 1 plus the square root of 1 plus the square root of 1, and it goes on forever. Remember that?
Yeah.
Okay, you think you can have something like that with this stuff? Yeah. Now, I don't want to do the same problem as homework. I think the problem tonight's homework is 1s, yeah? Did anybody work ahead? No. Okay, so let's do a different number. How about...
2.
Can't do it. 2 plus 2 over 2 plus 2 over 2 plus 2 over 2, and it goes on forever like this. Tonight's homework is ones. So if I show you this, you can do tonight's one, right? Now, the thing that makes this is called a continued fraction, by the way. You know who was really good at continued fractions? The greatest mathematician in the history of India.
Mr. Park.
Does it sound like I'm from India? Does it look like I'm from India? No! Takana. Greatest mathematician in the history of India. Mason. And don't even try the others then, right?
No.
Srinivasa Ramanujan.
Oh, that was my
That's what I
second
was gonna
guess.
say.
Anyway, you could give him any number, and he could write a continued fraction for it.
What?
Yeah, he was incredible. In fact, he was like so good, but see, he wasn't formally trained in mathematics. So there was this super famous mathematician in India, in England, and he went to India because he heard about this guy. But this guy, he wasn't formally trained, so lots of his stuff was like he just kind of did it in his head. In fact, he used to say that he would be like sleeping at night, and then he would dream of blood.
What?
And then he would wake up and he would have a mathematical epiphany.
That's weird.
Yeah. Anyway, he took that guy back to England with him and he kind of showed him off.
Drugs.
No. No. Because because of all the stuff he could do, he's the most famous mathematician in the history of India. Anyway, I don't know what this number is. I'm going to call it. What did we do with this problem? I don't know what this number is. I'm going to call it X. Okay, same thing here. I don't know what this number is. I'm going to call it X, or whatever letter you want to use. Now, what is X? 2 plus 2 over 2 plus 2 over 2 plus 2 forever, right? Okay, now watch this. What did I just circle? X. Because look, what's in the circle? 2 plus 2 over 2 plus 2 over, that's X. And the reason you can do that is because it goes on forever. If it didn't go on forever, you couldn't do that. So this is the same thing as 2 plus 2 over X equals X. Can we solve this equation? Yeah. Multiply through by to get rid of the fraction. Equal X squared. Hey, it's a quadratic. Make one side 0. X squared minus 2x minus 2. Hey, can I factor this or do I have to use the quadratic formula? You gotta be kidding me. You use the quadratic formula and you get, Mason?
Oh.
1 plus or minus root.
Oh. 3.
There you go. Box that, that's the answer. No. How can this be equal to two different numbers? It's either one or the other. Which one do you think it is? Just take the positive one. See, that's what you guys did last time with this. No! What is that number right there?
2.
2, and then you're adding stuff to it. So shouldn't the answer be bigger than 2?
Yeah.
Which of these answers is bigger than 2? Yeah, that one. So that's the answer. Don't just take the positive one. Because what if I put, instead of the plus signs, what if I change them to minus signs? Then the answer would have to be smaller than 2. But of course you would get a different answer here. That's why don't just cross out the 1 over there. You guys gotta think. Okay, we are done. So, believe it or not, there's only one more lecture in this chapter, which is on Monday. So we're gonna do that.
And when's the test then?
No, because it's extended, so it's gonna be Friday. We don't wanna have a test on extended. Because I think we have to start watching Flatland.
What's Flatland?
Flatland is these beings that live in a two-dimensional world. See, this is to help you understand higher dimensions. Because we live in 3 dimensions, right?
Yeah.
But are there beings in 4 dimensions that we just can't see? In fact, what does 4 dimensions even look like? Weren't you in the class last year? Wasn't I telling you guys?
Yeah, but I forget.
So what we do is, instead of thinking about 4 dimensions, we think about lower dimensions. And we do it by analogy. So can you think of people living in a two-dimensional world? That's what the book Flatland is called. Nobody read that? Usually there's just 2 or 3 people that read it when they were kids. Okay, people living in a plane called flatland. So like women are line segments, and then men are polygons. And the more sides you have, then the higher up in society you are. So,
Oh wait, so degrading.
well, that's the book. Okay, the book was written in the 1800s, I believe. So everybody aspires to be a circle because that's like a polygon with an infinite number of sides, yeah? But women are just line segments. And women, well, that's the book. I'm just telling you the book. And women are very dangerous because think about it. What if, okay, this is you, and a woman is approaching you like that. Could you even see the woman? The line segment is just going straight into you. You cannot even see. So that's why when women walk around, they have to give out these sounds, these shooting, like that. So you know that they're there, because otherwise they could kill you. No, I'm not making it. This is in the book. Plus, it's going to be in the movie that we're going to watch. Okay, now, I'm a 3-dimensional person. I'm a 3-dimensional person. These people that live in the plane, their whole universe is only the plane. They only know what's in the plane. They only can see things in that plane. But I'm in a higher dimension. I'm in a 3rd dimension. They're in 2 dimensions. Like if I'm standing right here, I can see them, right? Can they see me? No, because, and don't say they can look up because there is no 3 dimensions for them. Everything is just only in the plane. So they can't see me because I'm not in their world. That's why I'm not in their dimension. But I can see them. Okay, now, what, can they hear me though?
Yes.
Yeah, they can hear me because the voice waves, the sound waves go into their brain, right? So they can hear me, but they don't see anything. What? Now, how can I make them see me? I have to go into their world. How do I go into their world? Like I put my arm in. Okay, so all they can see is what's in this plane. So what if I put my arm in and up to the wrist? So they're gonna see, they only can see a cross section of my arm, which is the wrist there, right? That's all they can see. Yeah, and then if I put my arm in further up to my forearm, oh, the thing got bigger. Right? And then I put my bicep in and the thing is just huge, right? Why is that funny? And then I remove my arm and then it's all gone. It's like magic to them. I can hear something, I don't see anything. Oh, but then I just saw something and it's getting bigger, it's getting smaller, and then it just disappeared. It's like magic to them.
Since it's a circle, doesn't that mean it's like really high, so it's like Jesus?
Okay, this is just a story. Okay?
I want to read.
Okay, so imagine, what if there were and look, you can actually see inside their body, you've got all their organs like this, right? No, this is in the story. So, what if there was something wrong with one of their organs? They have to get their own doctor, and then they gotta operate, right? So the doctor has to cut open something and then operate and then patch it up, right? But look, I'm 3-dimensional. I can see. So if they have an organ that's not working, I can just do this. Fix it. And they're all well. And they don't even know what happened. So imagine if a 4th-dimensional being tried to visit us. It would be like the same thing. Can we see them? Only if they enter our dimension, right? If they're out of our dimension, we can hear them, but we don't see them. Right? And if they wanted us to see them, what would they do? They would come into our 3-dimensional world, but we're only seeing a cross-section of what they really are. But their cross-section is 3-dimensional.
This is confusing.
You know what I mean? So, like we're just standing around, all of a sudden we hear something, we can't see anything. It's like, you can hear it, it's like right here, but you can't see anything. And then all of a sudden, whoa! It comes up and it's big green, and it disappears. Exactly. That's my theory. So you know ghosts, like that, what people think they're ghosts, could they just be beings from another dimension?
Could they?
right? You hear sounds, you don't know where it's emanating
Why
from.
do they pick some?
And then they appear, disappear at will.
Should write this
No, I'm serious.
You should write a book on it.
The book is already written, it's called Flatland.
No, on your
That's
ghost
good.
theory.
That was just, I don't know.
That's exciting.
Okay, let's see if this worked. This